Okay, yes. Hi guys, a very good evening everyone. Welcome once again to Om Institute, your favorite institute, your favorite preparation platform for GATE engineering services and all technical examinations for electronics, electrical and instrumentation students. Very good evening everyone. Come on everybody, quickly keep on connecting and do update your friends that the session is now live. All those preparing for gate 25 or gate 26 can get benefits from this session because we are learning different concepts through PYQs this time. Okay, right. So we had two sessions on control system earlier where we discussed about steady state errors. In another session, we discussed about time response analysis. Today, we'll talk about an important absolute stability criteria, that is Routh Hurwitz criteria. Very good evening, Sai Krishna. Good evening, Ravi Teja. Okay. Okay, I think so. Let's get started. Okay, just quickly let me know if there is any issue with the audio video. If not, let's proceed forward as always. Yes, at my end looks all good. I don't see any issue. So let's get started up. Very good evening once again, everyone. Okay, so this is a regular intro about me. Let's get moving ahead. Important update for all of you that yes, on the occasion of Engineers Day, which was yesterday, 15th of September was Engineers Day, and on the occasion of Engineers Day, the Om Institute brings to you the special Engineers Day offer for all the online live courses. Yes, guys, for all the online live as well as recorded courses. For all the online courses, a flat 15% additional discount. Okay, and although the Engineers Day was yesterday on 15 September, but this offer for all of you is valid till September 20th. Okay, so if you want to enroll, okay, or if you have juniors or if your friends would like to enroll, you can pass them the information. September 20 till September 20, they can avail additional 15% discount on all the online courses of Om Institute. Just have to use the code OM15 while purchasing any course. Very good evening, Niranjana. Okay, dear. So now let's get moving ahead, and this is the first question for the day. The open loop transfer function, okay, of a unity gain, okay, open loop transfer function of unity gain negative feedback system is given to you. GS equal to K upon S square plus 4S minus 5. The range of K for which the system is stable. Now for stability, okay, we need to check the poles, okay, which are also equal to, okay, for stability, we need to talk about the poles of the system, and the poles of the system are also equal to what? Are also equal to the roots of the characteristic equation. What is the characteristic equation in general? Okay, we know this already. The characteristic equation of the system is given by 1 plus GSHS equal to 0. Okay, now is this question actually a Routh Hurwitz question? Let's just start solving it. So what is the characteristic equation here? Characteristic equation will be 1 plus GSHS. This is GSHS is 1 because it's unity feedback. Okay, it's unity feedback. So 1 plus K upon S square plus of 4S minus 5 equal to 0. Solving which I shall be getting S square plus 4S minus 5 plus K. Let me write it as K minus 5. Okay, now you have a second order equation primarily, correct? Okay, you have a second order equation, and up to second order we don't need any Routh Hurwitz. Okay, that is the reason I'm especially starting with this question, because many students here, okay, will start applying Routh Hurwitz, but okay, up to the second order you don't need any Routh Hurwitz criteria. Okay, up to the second order we don't need any Routh Hurwitz criteria. Let me rewrite the characteristic equation. What is that? S square plus 4S, okay, plus of K minus 5 equal to 0. So what is the criterion you need for second order? This is a second order characteristic equation, right? And up to second order characteristic equation, if all the coefficients are of same sign, then the system will be stable. All roots will be in the LHP. So look into it. All coefficients must be of same sign. This is plus, plus, and it should also be plus. This is what is dependent on K. That means K minus 5 should be positive or K should be greater than 5. Okay, for the system to be stable, K should be greater than 5. Simple answer, option number C. You don't need any Routh Hurwitz criteria to be applied here. You don't need any Routh Hurwitz criteria to be applied here. K greater than 5, option number C is the very correct answer. Okay. The second order characteristic equation, what I only need is all coefficients of same sign. Okay, this is what is the necessary as well as sufficient condition okay, to ensure that all the roots are in the left half plane, right? Okay, fine. Moving ahead to the next question in that case. Okay, so what is the next question here is gate 20 EC 2 marks question. The previous one was simple on second order, so it was a 1 mark question. Okay, taking this one. Which of the following options is correct for the system shown below? Okay, so now you have a 2 marks question and you have to first of all tell what is the order of the system and whether it is stable or unstable. Okay, order and stable or unstable. So first of all, for stability as well as for order, we can first directly write down the characteristic equation, dear. What is my characteristic equation again? 1 plus GSHS equal to 0. Okay, 1 plus GSHS equal to 0. Okay, and what is GS? 1 upon S plus 1 into 1 upon S square. This is GS multiplied by the HS, which is 20, is divided by S plus 20 equal to the 0. Okay, this is what I need to solve. So what is the equation? S square, S plus 1, S plus 20 I have multiplied throughout. Then what I am left with is plus 20 equal to 0. So let's solve it up. The S power 4. Okay, then this is 1 plus 20, 21S into S square. So 21S cube. Next, 1 into 20, 20 into S square plus 20 equal to 0. Equal to 0. So definitely it's fourth order. That is what we are able to know. It is fourth order. Okay, and other than that, other than the fourth order condition, one more thing, right? Vamshi, only common subject book should be available. You just contact the number once. Okay, you will get the guidance there. It should be available. They'll guide you. Just contact our Home Institute number. You can find our Home Institute number on the website. Okay, Vamshi, I think they'll guide you easily. It's available. Only common subject also you can purchase. Okay, so it's fourth order. Now, stable or unstable? Normally, we think again, it requires Routh Hurwitz criteria. But again, let me show you, dear. Again, let me just do a basic calculation here. What is my characteristic equation? S power 4. Where is that question gone? S power 4 plus 21S cube plus 20S square plus 20 equal to 0. Okay, now do you need to solve Routh Hurwitz criteria here? No. Okay, because you see that there is a particular term, S power 1 term, which is missing. Okay, which is missing. So see, whenever we want to check about the location of poles, whether they are in LHP or not, for stability, all the poles must be in the left half plane. That is what we want. Okay, so see there are two things here. Number one, necessary condition, and number two, sufficient conditions. Okay, up to the second order I told you, all coefficients must be of same sign. That is necessary and sufficient both. But for higher order, okay, for higher order system, higher order means, when I say higher order means third or more. What is the necessary conditions? Necessary conditions are, number one, all coefficients must be of same sign. This is required here also. Must be of same sign. Okay, and number two, all coefficients must be present. Okay, so now when I say S power 1 term is missing, that means its coefficient is 0. Okay, and you can directly say here, if the S power 1 term is missing, system can't be stable. That is, we can clearly say system can't be stable. Necessary condition itself fails. Okay, so if by the knowledge of necessary conditions, we can say that the correct answer is option number B, fourth order and unstable. Yes, Suraj Rai, correct answer, it is B, fourth order as well as unstable, without applying Routh Hurwitz here also. Okay, although it's higher order, but we don't want to apply Routh Hurwitz because the necessary condition fails. What are the necessary conditions? All coefficients must be of same sign. So, okay, all are plus, but all must be present. So, here the coefficient of S power 1 is 0. Okay, so all must be positive. Positive means strictly positive, not even 0. If it is a 0, that means it's a missing case. Okay, so system can't be stable. Now, if necessary conditions are by chance satisfied, then we go for what is the sufficient conditions. What is the sufficient condition? And for the sufficient condition, we solve Routh array. Okay, we solve Routh array. What is the condition? all coefficients in the first column of the Routh array, okay, must be of same sign. Must be of same sign. Okay, must be of same sign. And secondly, second condition, there should not be ROZ. There should not be ROZ. There should not be row of 0 actually. Okay, there should not be row of 0. Now we'll see both these conditions coming up. Okay, we'll see both these conditions coming up. And if there are sign changes in the first column of Routh array, that many RHP roots are there. That many RHP roots are there. That is what I can say. Okay, number of RHP roots. That is what I can say, dear. Number of RHP roots is equal to number of sign changes in the first column of the Routh array. Okay, so previous question was done because necessary condition failed, system can't be stable. So it is option number B, fourth order and unstable. Now let's move ahead to next question. Now let's move ahead to a next question here. What is the next question here? Yeah. A system with the open loop transfer function Gs equal to k upon s, s plus 2, s square plus 2s plus 2 is connected in a negative feedback configuration with the feedback gain of unity. For the closed loop system to be marginally stable, what should be the value of k? For the closed loop system to be marginally stable, what should be the value of k? What should be the value of k? Yes, tell me, what should be the value of k? Okay. Now see, let's form the characteristic equation, dear, once again. Let us form the characteristic equation. What is that characteristic equation? Again, 1 plus GSHS, HS will be 1, unity feedback is mentioned. Okay, feedback gain of unity is mentioned and GS is given to me, k upon s, s plus 2, s square plus 2s plus 2 equal to 0. Okay, so we need to solve it up. The s square plus 2s, s square plus 2s again. So s power 4, 4s square plus 2ab, so 2 to 4 s cube, then 2s square again, then 2s into 2, then 4s plus k. Okay, just forming the characteristic equation and rearranging the terms. S power 4, then we have 4s cube, 4 into 6s square plus 4s plus of k equal to 0. This is what I have. Okay, this is what is the characteristic equation, which is fourth order. All coefficients are of same sign. Yes. Okay, that's what. K should be of same sign. That means plus. Okay. What should be the value of k for the marginally stable? We'll see that here Routh Hurwitz is required and all coefficients are present. S power 4, S power 3, S power 2, S power 1 and the constant S power 0 term. Everything is present here. So here we should definitely go for the Routh Hurwitz criteria. Okay. For which I will take the Routh array now. Now, how do you form the Routh array? See, let me write down the characteristic equation once again. S power 4 plus 4s cube plus 6s square plus 4s plus k. Okay, Routh array will start, okay, with the two rows s power 4, the highest term available, s power 4, and then the s power 3 row. What will be the coefficients of s power 4 row? Okay, alternate 1 and 6 and k. 1 and 6 and k. Okay, so 1 and 6 and k. What will be the coefficients of s power 3 row? Starting from here, s power 3, alternate 4, that's it. 4 and 4 and 0. 4 and 4 and 0. Now s square, next row. What is the next row? Is the s square row. Okay, what is the next row? Is the s square row. Good evening, Raj. Okay, so what is the s square row? Now see, 4 into 6, 24. Minus 4, 20, 20 by 4, this is 5. Okay, so how do I solve it? Okay, we just cross multiply in the opposite manner. Opposite manner means opposite to that of determinant. If you are solving a determinant, you cross multiply this way, 1 into 4 minus 4 into 6. But here we cross multiply reverse, 4 into 6, 24 minus 1 into 4, 20 divided by the first element of the above row. Okay, divided by the first element of above row. Okay, which is equal to 4. So 20 by 4, 5. Now, whenever you are solving for next element here, okay, in the determinant, first column is always the fixed 1, 4. Next column will keep changing. Okay, like I am solving here, this is the next column. When I am solving here, this is what will be my next column. Okay, so this is your first column, this is your second column. Now cross multiply 4 into k minus 0. Okay, so that is 4 into k divided by 4 divided by first element of above row. Okay, first element of above row. Okay, so 4 into k divided by 4, it should be equal to k. It should be equal to k. Last element 0. Okay, now s power 1. Okay, now s power 1. Okay, good evening Raju Nayak. Okay, Raj will plan EMFT also, don't worry. Okay, so now coming to the next row. Again, next row, same manner. 4 into 5, 20 minus 4k. So 20 minus 4k. Let me write down here 20 minus 4k divided by 5 divided by the first element of above row. Now see, when you write down the element here, look into the column. This will be the next column to be taken. Okay, entire column 0, value of determinant will be 0. Okay, so this is 0. And similarly, last element of a row will always be 0 because what is the next column here? Nothing, 0, 0. So this element will also be 0. Okay, now last calculation left, I think, s power 0. We have to come to the last s power 0 row. Okay, Suraj says answer 5, very correct. Okay, now look into it. Again, cross multiply. Suppose this is x into k minus 0. Okay, so x into k divided by x. So only k will be left. Only k will be left. This is 0 because the entire column is 0 here. Last element always 0. This is where I am left with. Now we have to do the analysis of the first column. Okay, we have to do the analysis for the first column. Now see, for the system to be stable, let's talk about everything with respect to this question. Although the question is on marginally stable system, okay, you will have 20 minus 4k equal to 0, k equal to 5 will come. Okay, but let me extend the question and tell you some more things. Okay, for the system to be stable, I told you what I need for stability. Stability means two conditions I told you. Stability means two conditions I told you. Number one, okay, no sign change. Same sign you want, that means no sign change. Where? No sign change. Where? In the first column. And second, no ROZ. And second, no row of 0 should be there. Okay, to ensure these points, to ensure these conditions, dear, okay, no sign change in the first column means 1, 4, 5. This is positive, means 20 minus 4k should be positive. Okay, and this also k, this also should be positive, and k should be positive. Okay, k should be positive. Okay, so to ensure this, what is the condition I've got? Okay, k should be positive. Okay, but at the same time from here you will get that k should be less than 5. 4k is 20, so 20 by 4, 5. Okay, so what is the range of k for stability? Suppose this can also be a question. Find the range of k for the system to be stable. Okay, for the system to be stable, k should be between 0 to 5. Got it? For the system to be stable, k should be between 0 to 5. K should be between 0 to 5 for the system to be stable. Okay. Now, what happens if k greater than 5? Okay, that means reverse if I do. For k greater than 5, system will be unstable. For k greater than 5, the system will be unstable. Okay, so what happens exactly at k equal to 5? Okay, what is the boundary between stability and instability? Okay, at k equal to 5, system will be marginally stable. Marginally stable. That means marginally stable system condition will come when you have a row of 0, because when k equal to 5, when you make k equal to 5, the entire s power 1, 0, 0, 0. Okay, 0, 0, 0. ROZ will come. Anyways, answer is done. Simple question. Okay, what is the condition for the system to be marginally stable? K should be equal to 5. Okay, it's a 2-mark question, gate 14 EE. Okay, so k should be equal to 5 for the system to be marginally stable. That is what I want. K should be equal to 5 for the system to be marginally stable. For the system to be marginally stable. Correct? Okay, now dear, whenever the system is marginally stable means it is oscillatory. Okay, means it is oscillatory. Let's extend the question. Let's learn some more thing. Okay, so for k equal to 5, I am able to say that system is marginally stable. That means the system is oscillatory. Okay, and if the system is oscillatory, it will be oscillating at some frequency. It will be oscillatory, it will be oscillating at some frequency, it will have a frequency, it will have a time period, everything. So what is that frequency of oscillation? So dear, at k equal to 5, you got ROZ. What was the row of 0? When I say ROZ, ROZ means row of 0. What is that row of 0? S power 1 0, 0, 0. And whenever you get a row of 0, we form auxiliary equation. What we form? We form auxiliary equation. Okay, from which row? You form the auxiliary equation from the row which is above the row of 0. You form the auxiliary equation from the row which is above the row of 0. Okay, so what is the above row of 0? S square row. So what is that auxiliary equation? 5 into S square, coefficient is 5, na? Okay, 5 into S square. Okay, next plus K, and every coefficient is alternate. So if this is 5S square, okay, if this is 5S square, this should be K S power 0. S power 0 means 1. So we only write K. Okay, now we can put down the value of K. What is the value of K for marginally stable condition? K is 5. Okay, so that means 5 if I cancel, S square plus 1 equal to 0. So S square is minus 1. So what is S? Under root of minus 1 plus minus J. Okay, and whenever the system is oscillatory, it will have a frequency of oscillation, suppose omega n, and the roots are given by what we know from time response analysis. The roots are plus minus j omega n. So S is plus minus j omega, which you can compare to plus minus j omega n, and then you can say the value of omega n is equal to 1 here. Whatever is the omega n on comparison, that is the frequency of oscillation. What is this omega n? If the system is oscillatory, it will have some frequency of oscillations. That is determined by using the auxiliary equation. Frequency of oscillation. Okay, if it is oscillatory, it will have a frequency of oscillation. That is given by omega equal to 1 here. Okay, omega equal to 1 here. Right? No. See, K equal to 0, practically you see, don't always look into mathematical point of view, Satyam. Okay, if you take K equal to 0, then the system itself will vanish. The GS itself is 0. Okay, this is GS itself is 0. There is no open loop gain. There is no characteristic equation that is framed. So don't look into the table only. I'm directly saying K equal to 0 is not a practically viable value to be considered. Okay. Chalo. And next thing to be noted, whenever you are trying ROZ, please ensure that ROZ is in the odd row. Okay. Good evening, Akhil. ROZ must be in the odd row. Okay. Like here, S power 1 row, which is odd. S power 1 is odd. Or power is odd. Okay. So that you have to also take care. Okay. Auxiliary equation will always be a even power equation, and ROZ will always be a odd row equation. ROZ will always be obtained in a odd power. Okay. S power 1 or S power 3 or S power 5, like that. Okay. So this is what, if sometimes they can ask you frequency of oscillation also, so that is also done. Clear? Frequency of oscillation if the system is marginally stable. Okay, if the system is marginally stable. Okay. If the system is marginally stable. Now come to this question. A closed loop system has the characteristic equation given by S cube plus K S square plus K plus 2S plus 3, third order. Okay, third order. So now very frequently, sometimes we get question on the third order. Very frequently we get the question on third order. Okay, suppose you have a third order equation, AS cube plus BS square plus CS plus D equal to 0. This is what is the in general third order characteristic equation, correct? Okay, so now see, if I apply the Routh Hurwitz here, let's create a shortcut for third order. Okay, so S cube coefficients are alternate A and C. S square coefficients are B and D. Okay, so S power 1, okay, cross multiply BC minus AD upon B. Last element of a row is always 0. S power 0, suppose this is X. X into D upon X. D. Last element 0. Okay. So of course, what do you want for the system to be stable? Of course, all coefficients must be positive. Okay, that is a necessary condition. A, B, C, D positive. So A, B, D are positive. You have to make this also positive. Okay, so what is the condition required for the system to be stable? What is the condition required for the system to be stable? It means BC minus of AD must be positive. That is, BC must be greater than AD. BC minus AD must be positive. Okay, so BC must be greater than AD. Okay, for the system to be unstable, so reverse will make the system unstable. BC less than AD. And the condition for the system to be marginally stable, BC equal to AD. Okay, now how do we remember this BC equal to AD? Okay, B into C and A into D. BC means product of inner terms. Okay, product of inner terms. AD means product of outer terms. Okay, product of inner terms inner terms means inner coefficients equal to product of is equal to product of outer coefficients. Inner coefficients equal to outer coefficients. Okay, BC equal to AD. This is the condition for the system to be marginally stable, and for stable, BC must be greater than AD. I am separating out this condition because it is important. Third order separate questions are there lot many times. So like this question, and not only this question, multiple instances are there where third order question are there. Okay, so for the system to be stable, what we need? BC must be greater than AD, inner greater than outer. Inner must be greater than outer. Okay, so that means K into K plus 2 inner. This is K into K plus 2 must be greater than 1 into 3. Okay, so basically we have an equation here, K square plus 2K and minus 3 must be positive. Okay, and we can factorize the left hand side actually. K plus of 3, K minus 1 must be positive. And for this to be positive, what is the final condition? Either K must be greater than 1 or K must be less than the smaller root, that is minus 3. Okay, minus 3. But at the same time, K must be positive also. Okay, at the same time, K must be positive. So this cannot be true because, okay, because 1, first necessary condition should be there. So K should be positive. Okay, K should be positive. Okay, so K should be positive and K should be greater than 1. Okay, that means K should be greater than 1 only. It is greater than 1, so automatically it is greater than 0. So what is the answer required? K greater than 1. Option number D it is. Option number D. For the system to be stable, K must be greater than 1. Okay. Okay, so for, you can use, okay, you can use these conditions for third order especially. Okay. Chalo. Done hai. This is K greater than 1. Okay. Let's move ahead to the next question. Let's move ahead to the next question. Okay. Yes, GATE 17 EC 2 marks. GATE 17 again IIT Roorkee here. Okay, so GATE 17, now this one again will take you towards auxiliary equation. Which one of the following options correctly describes the location of the roots of the equation s power 4 plus s square plus 1? Only even powers are there. Okay, only and only even powers. Only and only even powers are there. Correct? Only and only even powers are there. Okay. So let's form the characteristic equation. Let's do it in the Routh Hurwitz. S power 4 plus of s square plus 1 equal to 0. Okay, s power 4 plus s square plus 1 equal to the 0. Okay, now when I take it to the Routh Hurwitz, dear, so normally what you will see, s power 4 alternate coefficient 1, alternate means s power 2 again, so this is 1, and s power 0 1. But what about s power 3? Okay, how do you write this as? You can write this as s power 4 plus 0 into s cube, okay, plus 1 into s square plus 0 into s, okay, plus 1 equal to 0. So when I want to see the s power 3 coefficient here, the s power 3 coefficient is primarily how much? 0, alternate is also 0. Okay, so s power 3 row coefficients is 0, 0 and 0. Okay, 0, 0 and 0. Okay, so in the very beginning you have ROZ and with ROZ we always form an auxiliary equation. With ROZ we always form an auxiliary equation. What is that auxiliary equation? From which row? Auxiliary equation, as I explained you, from the row above the row of 0. So what is the above row of 0? S power 4. So 1 into s power 4, 1 into s square, okay, 1 into s power 0. Okay, which is here equal to characteristic equation, which may not always be equal. Auxiliary equation, okay, sometimes may be characteristic equation, or we can say that auxiliary equation is mostly a factor of characteristic equation. Here it is equal to characteristic equation, but that is not necessary. Now, because we have a ROZ, because we have a row of 0, we can't proceed forward. How to solve for the next row? Because this is the entire row 0, all elements here will be undefined. Okay, so to form the next row, okay, to form the next row, we bring a modified s power 3 row. What we do? we bring a modified s power 3 row. The row of 0 will be replaced by the modified s power 3 row. What is that modified s power 3 row? To form the modified s power 3 row, differentiate the auxiliary equation. Differentiate the auxiliary equation. So what do you get? 4s cube plus 2s equal to 0. Now see the coefficient of s power 3. Now see the coefficient of s power 3, which is 4, will be written in this modified row. Okay, this is how much? 4. Then alternate coefficient s power 1, 2. Nothing is there, so 0. Okay, now what I will do is here, now I will continue with the Routh array in the regular manner. Now I will continue with the Routh array in the regular manner. Okay, so now see, 4 into 1. See, when I am solving Routh array, now this is not required. This modified new s power 3 row will be taken to solve. Okay, so 4 minus 2, 2 by 4. So this is 1 by 2. 4 into 1 minus 0. So that is 4 into 1 divided by 4. So 1 is left. Last element always 0. Now s power 1. 1 by 2 into 2, 1. 1 minus 4, minus 3. Minus 3 upon half. So 3 upon half, 6. So I will write here directly minus 6. This will be 0 because you see the entire column on the top is 0. Last element always 0. S power 0. Okay, minus 6 into 1 divided by minus 6. So 1 and 0 and 0. Okay, correct. This is what is the last row, s power 0 row. Okay, so Suraj says answer D. Okay, okay, let's check it out now, Suraj. Just recheck it once. Okay, now you see, this is the complete Routh array. This is the complete Routh array. Okay, now, how many roots are there? How many roots are there? Okay. Looking into this, how many roots are there in the RHP? Okay, number of sign changes, if you see here, okay, if you see here, number of sign changes, okay, it's 1 by 2 to minus 6, sign change, plus 2 minus, minus 6 to plus 1, this is also a sign change, plus 2 minus, minus 2 plus, both of them are known as sign changes. So how many sign changes? 2 sign changes, so 2 RHP roots for sure. Okay, 2 RHP roots for sure. Okay, so 2 RHP roots for sure, and that is satisfied only by one option, that is option number C. Okay, I'll tell you more details about this question. Okay, but here I am able to say only 2 RHP roots because of 2 sign changes. Okay, number of RHP roots of the characteristic equation is equal to how much? Is equal to, as I told you, is equal to number of sign changes in the first column. In the first column of Routh array. Number of sign changes in the first column of the Routh array. Number of sign changes in the first column of Routh array, which is equal to how much? There are 2 sign changes as I have shown you, which is equal to 2, and hence only option that matches here is C. Only option that matches here is C. Okay, only in option number C I am able to say that there are 2 RHP roots. Okay, there are 2 RHP roots which is there only in the option number C. Okay, so of course remaining 2 LHP. Why not imaginary axis? That also I'll tell you. But yeah, option is matched. 2 RHP roots, option number C. 2 RHP roots, option number C. Okay, now dear, actually there is one thing that you should remember for auxiliary equation. Okay, there is one thing that you should remember for auxiliary equation. Okay, so see, roots of auxiliary equation. Okay, what are the possibility? What is the little bit more detail? Let us learn. What are the possibility for roots of auxiliary equation? Whenever we have auxiliary equation, there are only and only 3 possibilities that may happen. Okay, there are only and only 3 possibilities that may happen. Number 1, okay, the roots of the auxiliary equation are, pure imaginary. S equal to plus minus jy format. Plus minus jy format. Roots are pure imaginary. Okay, second condition, the roots are real. Okay, the roots are both real but equal magnitude, opposite sign. If suppose you have x, this will be minus x. That means plus or minus x. Okay, both are real. Okay, having equal magnitude and opposite sign. Okay, so plus and minus x. The third possibility, any of this possibility may occur with auxiliary equation. The third possibility is a quadrature of the poles, okay, of this kind. That means if there is x plus jy first quadrant, there is x minus jy, its conjugate. Symmetrically, there is also minus x plus jy and then its conjugate minus x minus jy. Okay, so the roots are plus minus x plus minus jy. Okay, in any of the case, now these are the only three possibilities that can happen, okay, with auxiliary equation. The roots of auxiliary equation, okay, maybe of the form plus minus jy, maybe plus minus x, or maybe plus minus x plus minus jy, and maybe, okay, two of these conditions can happen, or maybe all three can happen, but nothing other than the three can happen. That is confirmed for auxiliary equation. Okay, now that means all these roots are symmetric with respect to origin. See, if this is origin, plus y above, y down, y above, y below, x left, x right, symmetry. Okay, now even if for all these four poles, if you calculate the distance from origin, every distance will be under root x square plus y square, symmetry with respect to origin. The roots of auxiliary equation, dear, please remember, the roots of auxiliary equation, okay, the roots of auxiliary equation, they are always symmetric. They are always symmetric with respect to origin. And also one more thing, in the case now, I told you now, these are only three possibilities that can happen with auxiliary equation. That means in the first possibility, how many left and how many roots of auxiliary equation to the left? How many left, how many right? 0. Here, how many left, how many right? 1 left, 1 right. Here, how many left, how many right? 2 left and 2 right. Okay, so because of this symmetry, okay, the number of LHP roots for auxiliary equation, I am talking about auxiliary equation, the number of LHP roots is always equal to number of RHP roots. Okay, and then how many RHP roots for auxiliary equation? Equal to number of sign changes, again in the first column of Routh array, in the first column of Routh array below the auxiliary equation. Okay, only below the auxiliary equation. Okay, only below the auxiliary equation, because I am interested in roots of auxiliary equation. How many LHP and how many RHP? They will be equal for number 1 point. And how many RHP? The number of RHP roots is given by number of sign changes in first column. But I am only interested in RHP roots of auxiliary equation. So number of sign changes below auxiliary equation, below the auxiliary equation, right? Okay. Okay. Yes, Satyam. So like in this question, what is the condition actually? In this question, dear, if you solve, na, see, I'll tell you, we don't need to solve it actually, but I'll just give you a hint. Here, s power 4, okay, what I have, for example, as I told you, s power 4 plus s square plus 1 equal to 0. Okay, what you have to do is put s square equal to x. Okay, so you will get a quadratic equation, x square plus x plus 1 equal to 0. Okay, and then you will get x as minus 1 plus minus under root b square minus 4ac by 2a. So x, which is s square, is minus 1 plus minus under root of minus 3, that is j root 3 by 2. Okay, and then what is s? When you solve for the under root of this complex number, when you further solve for the under root of complex number, okay, you solve when you get that format, plus minus x plus minus jy, case number 3, you will get that format. Okay, once you solve this, okay, we don't need to solve the characteristic equation, or we don't need to solve the auxiliary equation also. Our answer is done. Our answer is option number C. But still, if you solve it up, you will get this condition number 3 for this question. Okay, acha. Now one more thing. Okay, one more thing. As I have already explained you that auxiliary equation, number of LHP roots is number of RHP roots. Okay, so what we can do is, dear, okay, auxiliary equation. Okay, let's write down the answer by the shortcut. Okay, in the shortcut, I will make two columns. One is the auxiliary equation, one is the characteristic equation. Okay, auxiliary equation order for the given question, it is 4. Characteristic equation is also 4. Here they are by chance same. Here in this question, characteristic equation is same as auxiliary equation, but not always. Now, for auxiliary equation, as I have been telling you, number of LHP roots is number of RHP roots. Equal to how much? Equal to sign changes. Okay, equal to sign changes in the first column below auxiliary equation. Where is the auxiliary equation? Okay, auxiliary equation is s power 4. This is the auxiliary equation. Now see from here, how many sign changes? 1 sign change, 2 sign change. 1 by 2 to minus 6 sign change. Minus 6 to 1, another sign change. So how many sign changes? 2 sign changes here also. 2 sign changes here also. Okay, so number of LHP roots is number of RHP roots equal to 2. So now tell me how many j omega axis roots. See, j omega axis roots are only possible with auxiliary equation. If there is no auxiliary equation, there is no j omega axis roots. There is no pure imaginary roots. Okay. Okay. That means imaginary roots are possible only with ROZ, because auxiliary equation will come only when you have ROZ. Correct. Okay. Auxiliary equation will only come when you have ROZ. Okay. When you only have ROZ. Okay. Right. So this is j omega axis. Okay, this is j omega axis. So how many j omega axis roots? Okay, so see how many roots of auxiliary equation? Total 4, because it is fourth order. Then we know how many L, how many R? 2 on the left, 2 on the right. So how many on j omega? Nothing is left. How many on j omega? Nothing is left. 0. Now coming to the characteristic equation, number 1, write down how many RHP roots. Okay, number of RHP roots of the characteristic equation is again number of sign changes in the first column, complete first column. Complete first column, how many sign changes? Again 1 and 2. Again 1 and 2. Okay, so how many RHP roots? 2. How many j omega? That is obtained by auxiliary equation. So you have to copy this answer here. How many j omega? 0. So how many on the L? 4 minus 2 plus 0. Okay, and that is equal to 2. That is equal to 2. Okay, so dear, for auxiliary equation, L and R are equal to number of sign changes below auxiliary equation. Whatever is left is on j omega axis. Here nothing was left. Whatever is left means total order minus number of LHP and RHP roots. Whatever is left is going on the j omega axis. Now come to the characteristic equation. First, what you write down? First, write down the number of RHP roots by the number of sign changes. Then write down the j omega. How do you write j omega? By the left hand side, by the auxiliary equation calculation. Whatever is left goes to the LHP. Okay, goes to this L entry. Okay, so this is how for characteristic equation, first you get the number of RHP roots by sign changes, then j omega roots by auxiliary equation knowledge, and then remaining goes to the LHP. Okay, remaining goes to the LHP. Hope this is clear. Everything about auxiliary equation. Okay, hope you are clear everything with respect to the auxiliary equation. Okay. Okay, coming to the next question then. Yes, gate 24 EC 2 marks. Consider a unity negative feedback control system with the forward path gain GS equal to K upon S plus 1, S plus 2, S plus 3 as shown. The impulse response of the closed loop system decays faster than e power minus t if what? Decays faster than e power minus t if what is happening? Tell me, decays faster than e power minus t. Decays faster than e power minus t. Now see, e power minus t, what is the Laplace transform for e power minus t? 1 upon s plus 1. E power minus at, 1 upon s plus a. E power minus t, 1 upon s plus 1. Okay, now if a response decays faster, what does it mean? See, whenever any pole is closer to the imaginary axis, here dominant pole concept is required. Okay, if poles are closer to imaginary axis, they decay relatively slow. Okay, and they are said to be dominant. Okay, they are said to be dominant. Okay, poles which are closer to the j omega axis. Okay, poles which are closer to the j omega axis in the LHP. Okay, they decay. Okay, relatively slow. They decay relatively slow and are dominant poles. Okay, because they will decide up to what time transient part will exist. Okay, and the poles which are far away from j omega axis, okay, far away from the j omega axis, they decay relatively fast. This is all done using the transient analysis. They decay relatively faster. Okay, and they die out quickly. They decay relatively faster and they die out quickly. Okay, they just like come and go, they die out quickly and are known as insignificant. Poles. This is where dominant pole concept theory is also applied. Okay, the poles which are closer to j omega axis are dominant. Okay, the poles which are far away are, okay, less insignificant normally we call them. Okay, so now the response decaying faster. Now, when the response decay faster, when the poles are away. Now, faster than what? Faster than there is a comparative. There is a relative term e power minus t, which is in the S domain 1 upon S plus 1. Okay, so impulse response of the closed loop system will decay faster than e power minus t. Okay, faster than e power minus t. Okay, if you have the terms which are to the left of this, which are far away from this. Okay, which are far away from this. So let me write it here in a proper manner. Okay. Yeah. So what do they say? Impulse response decays. Impulse response decays faster than e power minus t if poles are located. Faster means left of this. Faster than e power minus t means poles are located, okay, to the left of the pole, minus 1, because this corresponds to 1 upon s plus 1. Okay, 1 upon s plus 1. So what is the pole? S equal to minus 1. Okay, so the response will decay faster than e power minus t if poles are located to the left of this particular pole. To the left of this particular pole. Correct? To the left of this particular pole. Okay, so this means that, let me draw a simple picture here. Okay, and then I'll tell you how to solve the question. So we have a pole which is at minus 1, okay. Number one thing, we have a pole which is at minus 1. Okay, what you want? Okay, you want the poles to be located to the left of minus 1. To the left of minus 1, anywhere. The pole may be real. I'm not telling only on the x-axis. The pole may be real, pole may be complex, anywhere. Okay, but it should be to the left of this pole. Okay, it should be to the left of this pole. That means if you want poles to lie to left of the line, okay, I have created a line passing through minus 1, and what is this line? Okay, this line is a line parallel to y-axis. Okay, this is a line known as x equal to constant. Line parallel to y-axis. X means sigma here. What is the x-axis? S is given by sigma plus j omega. What is the real part? Okay, sigma. What is the imaginary part? J omega. Okay, so line x equal to constant means line sigma equal to constant. What is that constant? Minus 1. It is passing through sigma equal to minus 1. Okay, so you want the poles to lie to the left of the line sigma equal to minus 1. What you will do is, dear, replace s by s minus 1. Okay, replace s by s minus 1 in the characteristic equation, and then apply RH. Okay, then you apply RH. This is the method to solve. Okay, so what is the old characteristic equation and what is the new characteristic equation? See, what is the old characteristic equation? 1 plus GSHS. What is the GSHS? This is the GS given to me. K upon S plus 1, S plus 2, S plus 3. HS is 1. Unity feedback. So 1 plus K upon S plus 1, S plus 2, S plus 3 equal to 0. Now what I told you? We will replace S by S minus 1. So what is the new characteristic equation? When you replace S by S minus 1, okay, S minus 1 plus 1 to S. S minus 1 plus 2 to S plus 1. S minus 1 plus 3, so that is S plus 2 equal to 0. Okay, solving which, now simplifying which, I get S cube plus 1 in plus 2, 3, S square plus 1 into 2, 2S plus K equal to 0. Okay. Now dear, actually what do you do is, it's S cube plus 3S square plus 2S plus K equal to 0. Now why do I ask you to do Routh Hurwitz analysis? See, basically when you replace S by S minus 1, okay, when you replace S by S minus 1, mathematically it means that the poles are being shifted 1 unit right. s minus 1. So all the poles are being shifted, okay, 1 unit to the right. So if there is a pole at minus 1, it will be shifted here. If there is a pole here, it will come here, 1 unit right side. If there was a pole here, it will go here, 1 unit right. Okay. So all the poles are shifted 1 unit right. Okay. Now you wanted, what you wanted? You want the poles to lie to the left of this line, sigma equal to minus 1. Okay. So because everything is shifted 1 unit right, okay, this pole, okay, which was to the right of this line now goes to the right of j omega axis. This pole which was to the left of the line, okay, maybe comes on the line. Okay, so basically it's like transformation of origin. We call it as a concept of shifting the origin. In a way you imagine, see, vice versa. Vice versa. What I have done is s by s minus 1 means poles are shifted 1 unit right. Forget the poles. Now let us shift the origin 1 unit left. Rather than shifting all the points to the right, what I do is, this is equivalent to what? This is equivalent to shifting the origin to the left. And if you shift the origin to the left, what happens? This becomes the j omega axis. This becomes j omega axis. Now what you want? You want the poles to the left of this line. And if this is the new j omega axis, okay, if this is the new j omega axis, that means you want the poles in the left half plane. To the left of j omega axis means to the left half plane. And how many poles lie to the left half plane? Routh Hurwitz criteria. Routh Hurwitz criteria can help you. Routh Hurwitz criteria can help you. Okay, so now what you want is, okay, now you want poles to lie in the left half plane. Okay, that means the system must be stable, and it's a cubic equation. Because it's a cubic equation, because it's a third order cubic equation, I will use the shortcut. What is that shortcut? Inner greater than outer. Okay, 3 into 2, the product of inner coefficients will be greater than that of the outer coefficients. So k will be less than 6. Question is, what is the value of k for the given question? So k should be less than 6. Okay, so option number A. Okay, for k less than 6, only option number A. There are different varieties given. Okay, so for k less than 6, option number A is completely fitting to satisfy k less than 6. To satisfy k less than 6, option number A is completely fitting. Okay. See, Muralidhara, in that case, you can put 0.025 or 0.026. Both are okay. If they say up to 3 decimal. Round off to 3 decimal place means 0.025, 0.026. Both are okay. Don't worry about such minute things, because if it is a fractional answer like this, they will evaluate in a range. Okay. Exact 0.025 they won't check. 0.025, 0.026 both is, they will give some range like 0.02 up to 0.03. Any such answer will be correct. So don't worry. Don't worry. Okay. Yes, Satyam, put z s equal to z minus 1 or replace s by s minus 1. Both is okay. Okay. So this is what is the method. See, with PYQs, I am telling you the method without deriving. I am explaining you how to solve. Okay, taking PYQs, okay, without deriving it up, but still I am telling you what is the method to solve. Hope that is clear to you. But if there is any method, problem in solving, if there is any doubt in solving, do let me know. Now I'll just show you one more type of question here. Dear, have a look into it. Look into this, a proper gate question once again, gate 16 2 mark question. Okay. Given the polynomial equation s cube plus 5.5 s square plus 8.5 s plus 3. Okay. The number of roots of the polynomial which have real parts. Okay. The number of roots, okay, which have real parts strictly less than minus 1. Real part. Now, what is the meaning of real part? Okay. Sigma. Okay. Strictly less than minus 1. So, you want those poles now, dear. What do you want? See, you want those poles. Whose real part is less than minus 1. You want those poles whose real part is less than the minus 1. Correct? Okay. So, you want those poles, see again, whose real part, okay, so now this is the real part, sigma equal to minus 1. You want sigma less than minus 1. Okay, so if this is sigma equal to minus 1, everywhere sigma is less than minus 1 on the left of this line. Okay, so poles having real part less than minus 1 means poles to the left of the line sigma equal to minus 1. And again, to solve this, what you do? replace s by s minus a, replace s by s minus 1, okay, and solve again by the Routh Hurwitz method, okay, and solve by again Routh Hurwitz criteria. Hope this is clear to you, and this is a homework, okay, because it's a similar calculation. So hope this is clear to you. Hope it will be clear to you, right? Done, dear. That's it. Okay. Similar question. Similar question. Poles having real parts less than -1. That means poles lying to the left of this line. Okay. Sigma equal to -1. Okay. Any doubts, any confusion, please do ask me. If any doubts or any confusion. Let me also give you some important updates that yes, guys, from 27th of September, you will have a new, fresh, an offline regular batch. Okay, for Gate 25 at our Hyderabad Center, live in front of the faculty. Enjoy the beauty and charm of studying offline. Okay, from 27th September, next batch for Gate 25. In case if you feel you can't travel to Hyderabad, you can't, have the offline classes, but want the same guidance by the best faculty team of home, same faculty team, same content, okay, same variety of questions if you want to cover, okay, and you want to cover at your hometown, you can also join our live batches, okay, the online live batches, okay. Which will be again in a live pattern. That means you can interact with the faculty one-to-one, same faculty, same best concept content given to you. Okay, for both Gate 25 and Gate 26, the batches are available. The fees is already mentioned, and you can watch these live courses, okay, on our Om Live app, okay, or on our website also on the browser ominstitute.live. You have to put, okay. Both for ECEE batches available. Okay, for any more details, you can contact 95156940553. Okay, at the same time, as I mentioned in the beginning also, okay, the special Engineers Day offer is there. Engineers Day was yesterday, 15th September. Okay, on the occasion of which for all the online courses, Om Institute of offering flat additional 15% discount. Okay, you have to just use the course code OM15 while purchasing the course, and this will be applicable till September 20th. Okay, till the 20th of 20 of this month. Okay, also guys, if you're preparing for AE, okay, whether for the AP exams like Transco Discourse or for the Discoms or for the Telangana State Transco exam or for the AEE examination upcoming for Telangana State, okay, the new batches for AE or AEE offline starts from 22nd September. Okay, 22nd of September. Yes, Satyam, same concept is there. That is why I left the calculation as homework. You just have to replace s by s minus 1 and solve further. Right, dear? Chalo, that's it. And as always, with respect to what we say, like the other classes. So this class also I'll share you the PDF, but the PDFs are password protected. Okay, what will be the password? I'll share you the PDF in the Telegram. What should be the password? I'll keep the password for today as let the password be stable. Randomly what I think, stable, ST, everything in small, STABLE. The password for today's PDF, which will be available in this Telegram. The name is mentioned here, like I've shared for other classes also. Okay, so similarly you will get this PDF by this password protection stable, STABLE. Okay. Yes, that also can be done, Satyam, pura RS table banake. Or else what you can do, if you notice that question, Satyam, it's a cubic question. Okay, it's a cubic question. Yes, we'll come to Nyquist also. Next I will take root locus. Probably after that I will take Nyquist. Okay. Okay, so no need for RH, Satyam, for the previous question because it is cubic equation. So you can use that BC and AD concept again, inner and outer. Okay. Okay, BC greater than AD, you can use directly. If it is above third order, you have to use the RH. That BC and AD also coming from RH only, that is just a shortcut. Okay. This one Telegram, you can join using this name directly mentioned here. G Shankar. Okay, dear, that's it from my end. Bye bye. Thank you. Good night. Stay safe. And the next session will be on root locus. After that, mostly I'll take Nyquist. Okay. Bye bye.